Okay guys, so this is the supplementary video for week 23, week 23. Sorry it took so long for me to upload the video. I've been really busy. Okay, so in this video, we're going to finish the last page of the class note, okay? We went through the first 3 pages in class, and in this video, we're going to focus on the last page. So on this page, we're going to learn the formula of the length of a line segment. Line segment between 2 points, okay, P and Q, where the coordinates of P are x1, y1, the coordinates of Q are x2, y2, okay? So the length of the line segment PQ may be expressed as square root of x2 minus x1 square plus y2 minus y1 square. Okay, so if we look at the diagram here, we can see basically the formula is based on the Pythagorean theorem, right? So this is the line segment that we're trying to find, right? We're trying to find the length of PQ, right? And we have Q, x2, y2, P, x1, y1, right? So if we draw 2 line segments that are perpendicular to each other, we can find that. So let's call this R. Okay. So we can see that QR is equal to y2 minus y1, and PR is equal to x2 minus x1, right? And since these 2 line segments are perpendicular, we can use the Pythagorean theorem to find PQ. This is the reason why PQ can be expressed as this formula. Okay, let's quickly look at the example. Calculate the length of the line segment joining the 2 given points, A 42 and B 16. So what we do is AB is equal to square root of y2 minus y1 square plus x2 minus x1 square. So 6 minus 2 square plus 1 minus 4 square. Okay, and this is equal to square root 6 minus 2, that's 4, right? 4 squared, that's 16. 16 plus 1 minus 4, that's minus 3. Minus 3 squared, that's 9. So this is equal to square root of 25. So the answer is 5. Okay, remember, technically the answer of the result of a square root of a positive real number, technically it should be 2 answers, right? Because both 5 and minus 5 squared can be 25. But here, because we're looking for the length of a line segment, it can only be positive. Okay, so here the answer can only be 5, not negative 5. And the other example, let's quickly go through this. So CD is equal to y2 minus y1 times, y2 minus y1 square plus x2 minus x1 square. So minus 1 minus 3 square plus 2 minus 4 square. Okay, so -1 minus -3, that's 2 squared, right? Which is 4, plus 2 minus -4, that's 2 plus 4. That's 6. 6 squared, that's 36 square root. And this will be square root of 40. Square root of 40. So 40 can be written as 4 times 10, right? And if we factor square root of 4 out, that will be 2. So 2 times square root of 10. That's the answer. Okay, so let's do the class practice. The vertices of triangle ABC are A5 -5, 4. So this is 0, 0. Okay, -5, 4. B 2, 0, and C -1, -3. Draw ABC and prove that. Okay, ABC. So okay, -5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is A. Okay, this is point A. B 2, 0, 2, 0. This is B, right? C -1, -3. -1, -3. So this is C. Okay, now we join the points. Oh, I didn't do a good job. But, okay, so let me try to do it better. Okay, so I think this is better. So the question is asking us to prove that triangle ABC is an isosceles triangle. Isosceles triangle means the two sides of the 3 sides of a triangle are equal. Okay, so actually we can see from the graph, AC and BC they look equal, right? They look the same, but that's not good enough. Okay, that's not really that's not technically a proof. So what we need to do is we need to use the formula that we just learned to find the length of AB, BC, and AC to see that whether AB and AC are actually equal. Okay, so let's do that. Okay. Let me write the formula here again, just to remind ourselves. So let's just say AB. So here, AB is a general name of a line segment. Okay, it's not the AB here, it's just a general name. Y2 minus Y1 square plus X2 minus X1 square. Okay. Okay, so now let's look at AB. AB is equal to square root of 0 minus 4 squared plus 2 minus 5 squared. Okay. 0 minus 4, that's -4. -4 squared, that's 16. Plus 2 minus 5, that's 2 plus 5. Right, and 2 plus 4, 7. 7 squared, that's 49. And 16 plus 49, that's 65. So the answer is square root of 65. Okay. So questions like this, the square root of 65, you can't really simplify this number any further, right? Because 65 is equal to 5 times 13. So they're both, they're both like there's no perfect square in the factors. So we can't really factor it any further. But questions like this, it's better to leave the answer like this because you want to compare the numbers eventually, right? You want to compare the numbers to see if the lengths are equal. So my suggestion is when you see this kind of questions, just leave the numbers like this, leave the answers like this. So it'll be easier for you to compare the numbers. Okay. BC. BC is equal to, so we use these two coordinates, okay? -3 minus 0, so that's 3, -3 square, plus -1 minus 2, so that's -3 again. Okay, so -3 squared, that's 9. -3 squared, that's 9. So the answer is square root of 18. Square root of 18. 18 can be written as 9 times 2, right? And square root of 9 is 3. So the answer is 3 times square root of 2. Okay. AC. AC, we use these two, right? So AC is equal to square root of -3 minus 4, that's 7, sorry, -7. And -7 squared, actually, let me write this out. So AC is equal to -3 minus 4 squared plus -1 minus -5 squared. So -3 minus 4, that's -7. -7 squared, that's 49. Plus -1 minus -5, that's -1 plus 5. So that's 4. 4 squared is 16. So 49 plus 16, that's 65. So the answer is square root of 65. Okay. AB is equal to AC. Okay, let's check. So AB is, let me use a different color. This is AB. Square root of 65. What about AC? Square root of 65. So we used the formula that we learned in this class. And we found the lengths of AB and AC to prove that AB and AC are equal. Okay. So answer is yes. Okay. Okay, so this is everything we need to cover in this video. If you still have any questions, please let me know. Okay, please make sure to watch the video before you handing the homework. Okay, and I uploaded the answer key video for week 21. So I'm going to make week 22 answer key video soon. Okay. Okay, guys, I will see you tomorrow in class.